Okay, so this is what our graph looks like. And what we're going to talk about is like what number like that left side is going to end up at and what number that right side is going to end up with. That's the idea with limit notation. So rather than writing the whole word limit, they just write LIM. So this is this limit notation. The limit of a function. And these are kind of look the same except for a very slight difference. It's saying as x approaches infinity, as x approaches negative infinity. So basically what this is saying over here is if I went way down, this would head to infinity, and this would head to negative infinity. So this is basically saying what does the right side of the graph do? And then what does the left side of the graph do? So this limit notation, it shows what value the graph gets closer and closer to as the graph goes on. Shows the value the graph is getting close to. And I'll show you guys what I mean using this example, and then we'll talk about. So as I go, let's actually do the left. The left's, maybe the right side's easier. So the right, let's start with the right side. So if I'm going to the right, as my x goes way this way, so like I'm over in Mr. Hatfield's room, what's my y value doing? What's y? So what's the black line doing? If I'm way over there, where's the black line going to be? Way up high, right? And it's going to keep doing that. So it's going to keep going up and up and up. Up and up and up never ends. So what we're going to say is that's going to approach infinity. So as we go to the right, my graph's going to keep getting bigger and bigger. So we're going to say it would approach infinity. Now we're going to go the other way, so going to the left. So if I'm going all the way over into Mr. Sampson's room over here, Mr. Sampson's room is now down here, so not to confuse you. If I'm all the way over there, what is the y value going to be of the black graph at that point?
Flat.
So it looks flat. What's that?
Just over there.
Over there. So use the trace button on your calculator. So if you guys have that on your calculator. So what basically I'm saying is what's the value of this graph, like way, just go to the right, or to the left, sorry, and see where you're at. What is the y value saying? What's it doing?
It's really big. I don't know.
Is it really big? Oh, so really good question. So hers says like 1 point something, and then e to the negative 11 power. Let me talk to you guys about that for a second. So it says like 1 point, let's say 1.5, and then it like, I think it says like e to like the negative 11. What does that mean? Does anyone know?
A really small decimal.
It's a really small decimal because e to the negative 11 means you're going to move that decimal point 11 times to the left. So negative decimal point or negative exponents mean this number is getting really, really small. So this is a really, really small number. Does the number ever become negative? No, so it's getting really, 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 really close to zero. Do we ever quite hit zero, does it seem like?
No.
No, but we're getting really close. So what we say then is we call that a limit. It's getting really close to zero. It never quite touches it as far as we know, but it's going to get as close as we can kind of like visualize or explain to zero. So that's what we call the limit on the left side of the function. So we're going to say the limit is going to be 0 over here. It goes as close to 0 as it can.
How do you get back to like
I usually just goes like zoom and then 6 standard. Yeah, you can just hit the 6 too if you have like a faster way to get there. Is that kind of what you mean? Yeah, kind of back to the home. Yeah, once you've like traced way over, if you hit zoom and then 6, I think most of your calculators, zoom standard, it like takes you back to like the normal screen.
I'm just gonna go zooming.
Then you always hit home. Home.
I wanna go to the line.
You can't. It like you
I went over so far.
You could spend the rest of your life looking. It's like looking for the end of the rainbow, Garrett.
I zoomed out like to 52 power.
Yeah.
It never
It wouldn't
ends
even-
here.
it wouldn't even let me
That's
zoom
why
in.
it's infinity.
Oh, try zoom in. Oh, wait.
Just keep going in, Garrett. Let us know when you get there.
I had to click the home button 3 times because I was so far away.
Okay. And I think I always pronounce this wrong. I like feel like I need to. It's horizontal, but then asymptote. There's probably a better. He says it differently. That sounds much better. So what the horizontal asymptote is basically like a line that approach. So so in this case, the line where y is 0 would be our asymptote. So So if I could picture almost like a boundary line there, that like, you know, like a dog is running along a fence and he just keeps running on forever. So Garrett is going to keep running along forever, trying to find the end of that fence. And that's essentially what's going on there. So that flat line is stopping him from crossing over. So it's basically the line that the graph is getting closer and closer to. Oh gosh, don't do that. Reset page, I don't even know what that means.
Not offering
No.
Work.
Right. Thank you, Maddie, that worked. So if it's horizontal, it's going to be a y equals. We will eventually talk about vertical asymptotes, and then that would be an x equals. So this limit notation is going to look a little strange just because we haven't seen it before, but we'll get there and we'll see it more and more often. Again, it's like just with talking with, you know, like next level class, like just that having that notation and not being afraid to use that is going to be helpful. All right.
I hit 0.
Oh my gosh,
It says 0.
it finally went to 0.
Yeah.
And you had to show for proof, just in case.
Yeah. Just Matthew saw it. Yeah, I saw it. It says 0.
All right, so the next one here is asking for the limit as x approaches infinity and negative infinity, for 3 to the negative x power. So again, we have to grab our graphs, 3 to the negative x. Again, graphing that by hand would be a big pain. I mean, you could. 3 to the negative x power. All right, so again, we're going to talk about the limits now in this case. I did a tougher equation, but it's okay. I guess we'll. Because they won't always be 0, so I just want to point out something real quick here. Let me just add something onto this. So let me go over here. Well, first of all, let's talk about this one. All right, in this case, Andy, make it work again. Work. Okay. So, as x approaches infinity, so infinity is as big as we can get, so that's the right side of the graph. So this right side of the graph, what is the graph going to approach this time? 0.
I mean, if we use math in this one, also do we just use 0, or can we use the numbers with the e's attached to them?
No, you want to use, because the number with the e is not what it's approaching. It's approaching 0. You're headed towards 0. Okay?
Oh, we're just limit. Oh, it's just a limit and not like the perceivable. But I don't know. I don't know what I was thinking.
No, it's okay. And then the left side approaches what? Is it negative or positive infinity? Yeah, positive infinity, really big number up there. If the graph was flipped, then it could be negative infinity. That's not an impossible thing to have happen. Okay. Does it have a horizontal asymptote?
Yeah.
Yeah.
So I got that one right.
And what's it going to be? Y equals 0. Okay.
Yeah, I got that one right too.
All right. And then it says, okay, so this part is kind of weird, and I personally am having a hard time showing it because I can't show it on my board. They want us to know, so this is maybe getting a little bit into like Cash was asking about the e values. I want to be within 0.01 of the limit. The limit is 0. So I'm hoping to be 0.01 within that. How far down on the x's do I need to go? So what I'm trying to get you guys to see is, so like if I go to 8 over here, I don't know if I'm able to do that on mine though. Like, so those of you guys who have the trace button, are you guys able to trace over until you hit, like you basically want to be under 0.01. So trace over till you get to that point. I'm trying to find out that x value. Sorry, so those of you guys on decimals, I don't know a way to do this on decimals.
What is it, x?
So we want to be within 0.01, so under a penny. Would you get, yeah.
Mine is not letting me grab.
Oh my goodness.
I got 4 points.
For what?
I got 4.54.
I got 4 points.
So I think yours is doing the same thing. This is flat, they need it to be not high enough.
Oh,
I
I
don't
got
know why.
4.5.
Okay, and mine's really slow too, but I think it's,
I think it's just.
yeah, it's
0.06.
So your x value that gets you under like 1 cent, so like it should be point.
Oh wait, what am I doing?
Yeah, so like 4.2ish.
I got wait, what? Did I spec out?
Your calculator sucks.
I'm not
Bro, imagine.
Let me actually look.
You're
No, just give it to me.
You guys are getting an error.
No, it's hot in here.
Hold up.
It sucks,
I don't know what I did wrong.
This calculator sucks.
It's just awkward.
But his calculator sucks.
Wait, you have to go until under 0.00.
Stone and
You go until under a penny. What is a
I
penny?
think if
Point
it's
zero
this
one.
negative,
So you go
it's
until
negative,
under a
not
penny.
minus.
Oh my god, any rod.
God.
Stop.
What do you mean stop?
Yeah.
But mine, look. 0.006.
Someone's calculator sucks.
So what's your x
How do you
value?
get to 0.001? I mean, 9. I didn't do that.
Stone, what's your answer? 4 point.
Yeah.
Go back.
I actually had these issues like started when I dropped my calculator.
4.54.
Okay, so we're in between like 0.24 and 54. And I'm wondering if it's your Windows setting. I don't know.
Yeah,
Look,
that's
I go
the
from
setting
0.11 to 0.006.
Yeah,
So my
It's okay.
calculator's not good.
okay.
Bro, this is my
Okay,
calculator.
what happens if I change the names?
Where's my calculator?
Okay, guys. Next one I'd like you guys to try and graph is the cosine of x. Cosine of x. So cosine is a button on your calculator, so hopefully you should be able to find that. Okay.
You do cosine of x. Just type in cos.
You do this button?
It works if you just type it over the top.
Otherwise, it's a function of some nature. But yeah, it recognizes that COS.
There's no space. Oh, right here in the function.
Yeah. Yeah. All right.
So,
Yeah. So like about 4.2, I think we got 4.4, yeah, 4.5, yeah, somewhere around here. That to get with that.
Does your front
Okay,
My podcast.
so guys, so this graph is kind of pretty, like it's kind of got nice little waves there, and I saw like Tara checking, and does it ever change how high or low it goes?
no,
So is it getting closer and closer to any one value?
no.
No. So it's totally possible that we don't have a limit. So something like this, that it's not changing, it's always going to go from 1 to -1, 1 to -1. It's not getting any closer to some other number. We say it has no limit. Okay, no, not quite. All right, I do want to show you guys a couple of other ones. If you guys could actually grab whiteboards quick, we're going to use whiteboards a little bit, but you also want your calculator.
Mine only goes up to 0.99.
What's the matter?
When I go here, it doesn't go all the way up.
That's super close.
Oh, okay.
Yeah.
Same thing that stones does.
Oh, yeah?
Oh.
Hey,
Really? Oh, that's on the get line.
dude, yeah. I can't wait till I can look past now and just absolutely destroy you.
Okay.
I can't wait to watch
Okay, it's not.
You wait 5 more times. You're getting laid off.
I don't want to.
No, I can put on hands and arms.
Hey, who you guys got money on? Who you got money on? Yeah.
What do you mean no? Shut up. Because tonight would be my 6th birthday. Yeah, but yours are
Alright,
this
what do you guys got?
Dude.
Stone and Garrett.
Yo, this one, come on! What is that one called?
Yeah.
Lay down. Some meat
Meat
grinders. And then they show them all. Meat grinders.
Cool.
Well, we did know that.
Meat grinders.
Good?
Yeah. I would fly it out.
No, you couldn't.
I don't think live in
I
air.
think like Eli might be good.
That's cat.
That's not like, I literally take you out. You're a cat.
Yeah.
Okay, my first year of class asked how many kindergartners I can take out.
Okay, who you got? Who you got in football?
I got $20 Garrett. $20 Garrett. I got
Alright, let's
$100 on stuff.
Yeah, yeah.
$100.
What? Yeah, that's
All
right.
day long.
I
I'm
was
sorry
seeing
to
missing
hear it.
tackles and stuff in the games.
I
We
played
got
one
this on
game.
here. We got this on here.
I played
Oh
one
my
game.
gosh, I don't
You
think
got
I can
it.
answer there.
I got
You
Okay,
can answer.
okay,
Five
so
stars.
guys,
That's right.
so I'm asking you guys about the limit. We are gonna finish the backside. I just wanna do a couple of problems where the limit's not necessarily 0 or just infinity. So if you guys can try this one, I wanna know the limit, so again, use your graphing calculators. The limit of -3 to the x power plus 2. So from the left and right side. So -3 to the x power plus 2. One of the things I talked about with Trey was watch out for the negative symbol. There's a negative symbol and a minus sign. Your calculator, a lot of your calculators recognize those as 2 different things. So you have to use the negative symbol.
Is the plus 2 is an exponent? No.
The plus 2 is not exponent. That should be big. How do you do that? So like arrow over them. There you go. Then plus. You shouldn't be in the exponential. You might have to arrow over to make sure you're not part of the exponent. Or you just put the x in.
Do we have to
And then-
put it in?
If
No.
you're having trouble seeing it, just always go zoom.
Bro, it means limits, dog.
You're allowed to see it.
Yeah, you hit zoom though. Oh, I didn't know what you were. Okay.
Yeah.
Zoom standard, so zoom 6 is kind of a safe way to get back to your home screen again. Oh, it's
I just have 2 dots.
Imagine not seeing anything.
It's not my head, it's one of my ace of 3 on the trace.
Is it not working on yours?
I
This
can't
is
see.
what I done.
Oh, yeah,
This is
why
what I
is yours
did.
different than theirs?
This one looks awesome.
Because mine's just
I like mine better.
Wait, you got this, right?
Did you get it?
Yo, you suck.
Are you guys,
you're a little.
did you use the negative symbol or
How
the
do you
minus
do
sign?
that? How do you do that?
I need a helmet.
Oh,
Okay.
then it like,
Go show you how to
you might not need the parentheses. Maybe try taking the parentheses off.
Yeah.
Yeah. Okay guys, so on your whiteboard, I want to know the limits on each of these. Oh, and then I want to know the asymptote, the horizontal asymptote. I'll come over and check. Yeah, take the parentheses off maybe. So, what? Let's talk about what's happening on the right side of the graph and what's happening on the left. So the top one's asking what's happening on the left side of the graph, what is it approaching, what's happening on the right side of the graph, and then is there that asymptote, that line that like the graph shouldn't like really cross. Where the line the graph is approaching. So left on top, right, and then
Did I do it correctly?
I don't know what the answer right now.
So isn't the wait, what's it called? Asymptote?
Yeah.
Isn't that the same thing as one of the two? Isn't it always gonna be the same? Or no? Did I
Yeah, oh yeah, it should match with one of your limits.
Yeah. So these are not two. This is right.
Yeah. You just want to write this one as an equation.
Oh,
What equation?
y equals.
I have a question.
Are there infinity downs?
Yeah, the infinity down, yeah, but you do not have yours right. It does have, well, it approaches something. It has
Oh,
a
negative infinity downs.
No, dude. What
Yes.
is this number trying to get to? Look.
Negative infinity.
No, it's not. Like, what's the line? What's the y value?
It's blue. Mine is blue.
You guys can send it. Yeah, you did.
Yeah. So it's really headed
Yeah, there is. Where's this
so
one?
it's headed, like it's leveling off.
No, down.
Oh, you don't use that with the limit. That's the number it's getting close to. Like it keeps going, and that's why that trace button is nice for
No, it
that.
couldn't. Because it's going negative infinity this way.
Okay, look, stop. I think your calculator is really bad, so I think I scared it. Oh, it's going
Okay, and I know this is sometimes a shift in your mindset, trying to get used to this new idea. I know we're used to like, kind of finding an exact answer. We don't necessarily want an exact answer. So the question, I've heard a few questions here. So on this left side of the graph over here, this graph looks like it's leveling off. Like it looks like it's a flat line. It is not constant. If you trace that, it's going to keep changing its size. But what is it heading towards? If you could keep going on forever, what technically should it end up needing?
2.
2. It doesn't exactly ever get there. Or some of you guys, if you want to keep tracing until you find it, again, pot of gold at the end, not a huge deal that we need to get there. So this would be 2. Yours does say 2.
Yeah.
Okay, eventually. Then, but on the right side of the graph now this time, it goes down forever. Now, it's going to keep going down, and again, you can keep tracing, but what's going to keep happening to that number? Will you ever reach like a limit? No, you're just going to keep getting smaller and smaller and smaller to a very, very small negative number, or a large negative number. I don't know how to say that. So that's how we use the term negative infinity. So yeah, there is a negative infinity just like there was over here. So that graph is headed towards negative forever. Now the flat line, that if I could draw a flat line to show where that graph is headed towards, is that 2. And so like Stone asked, isn't it always like one of these two? It probably is. But you just have to write it as an equation, so it's y equals 2. Okay? Let's try one more before we move on to a little bit different topic. We'll do we only have time for like an announcements break, but I apologize that we don't have.
No, the one.
Sorry.
Can we do the announcements outside?
Yeah.
Probably not. I have a slideshow for announcements.
Oh.
It's for homecoming.
I can't wait for the dress up girls.
You should just tell everyone to check their emails.
They could.
And then we go outside.
Yep. I agree.
We can just
go outside.
That's it.
Yeah.
Do what?
Okay, try this one.
Oh, yeah.
Okay, so totally different equation, or very different equation from what we've seen before. So it's 5 plus 1 over x.
Wait, what was well, whatever word it was for the second one.
Horizontal,
This word.
asymptote.
Yeah, what was it for the second one?
There's only the one. There
There's
should only be one horizontal, so it's that flat line that it's approaching.
I just deleted it. Oh. So the only.
When it's like a fraction, should you put
You can, you can choose divide by. It's like 2 different graphs. It does, yeah, craziness. It looks like a little cross. Mind blown. All right. All right. Don't let the graph throw you off too much. Again, we're looking at the ends. So we're looking at the left side and the right side and what they'd be approaching. What are those headed towards? Okay. So if you look at the left side of the graph, where is that graph headed? To 5. If I kept going on forever, you probably would get some number really close to 5 or even get 5. So depending on if your calculator tells you that. So it's going to be 5. How about on the right side of the graph?
5.
Also 5. That's our limit. Our graph may never actually reach that, but it gets super close, almost to a point where we don't even understand how small of a difference that is. What would our horizontal asymptote be here?
Y.
Y equals 5. So flat line at 5. Is that okay?
Yeah.
Why don't you guys clean up boards?
Let's see.
I do.
That he ain't worth that lesson.
Bro, look at you. I'm not a drunk.
No! Imagine if I would get so mad.
Good one, Trey.
Dude, no.
Yeah, exactly. No, he was yeah, Hey, you're funny. Thanks. I know it's bad.
7:30 to 11. Again, if you need a guest form, that has to get taken care of by next week, Thursday. Help with class activities throughout the week, starting with Sunday window painting. You must follow dress code for homecoming dress up days. Yes. All right. Next week, Monday, is dress like your favorite animated character. So you can go all out or go simple. I expect one of you guys to bet Mickey costume, by the way.
I guess I will.
All right. So, Monday night is the Carter Cup girls football game. That's next week, Monday. It's on Monday because of the JV boys having a football game, and then they can't do volleyball that night. So Carter Cup is girls is starting the week. It's Monday at 7:30. It's $2 to get in for non-athlete or like not the players, or 2 canned food items. We're gonna donate to the food pantry. Sign up with your class.
That's what I'm saying.
Stunt double day, Twin Tuesday. Boys soccer play that night against Howard's Grove, hoping for a blowout win again. Alright, Wednesday is tourist day, or like our day in Hollywood. So freshmen dress as tourists, sophomores as bodyguards, juniors as paparazzi, seniors are celebrities. So I try to give you a few little examples there.
The Rock. Yo.
Yeah, The Rock and Kevin Hart as The Rock.
Yo.
That was Mr. Donahue's suggestion.
Is that pickle?
What's that?
That's a bodyguard.
I'm
It's
so excited.
Julia Jean.
My ball
When
cap.
I searched bodyguard, like sexy bodyguard costumes came up. And I was like,
Yo. All right.
Okay. Powder Puff Boys or Powder Buff on volleyball is on Wednesday. Sign up to play with your team. Wednesday at 7:30 here in the gym.
That's tough. Can't tell.
We'll talk to them.
We have CCD, so like
Wait,
Rob
then
and
it's
Kyle
not really
do
not
and
either.
then
Sundays.
Wait.
No.
That was probably.
He's got to play Powder Buff volleyball, so he
That's
can't.
Tell me you can't come.
Just go
All right.
Kids, you're not allowed to skate.
That's messed up. That's why I think that.
Normally, like, I don't think you can do like just like switch.
So, Thursday is class shirt day. Wear your class shirt. If you, I said staff should wear a throwback, so I put a throwback photo of cute Miss Dunn. I need that here. All right. Thursday night is away sports, so volleyball and cross country are away next week. And then Grand Prix Day on Friday, football game that night, and then the dance.
Yo,
is at
Have fun. Have fun. Are advantage.
No. First, it's just
Yeah, because.
And then I don't know if there's any other new announcements to look. Patrick Club meets today, FFA meets today, FBLA meets needs money by Friday.
Do you want me to put up on it?
Remember, Pleasure Valley Pumpkin is looking for face painters. Art Club is meeting next week Friday. Fitness Center, if you guys are thinking about working on the fitness center next week during AR, you have to sign up by tomorrow in the office. There's a maximum of 20 students per day, so get signed up. Newsletter jackets, incentive days, make sure you guys take care of business that probably needs to be turned in already.
I'm only showing it to the first class and then I have.
That's about it.
Can you say that louder so I can hear it? Say it again. Can you say it again?
Okay. Okay guys, so I'm gonna teach you guys a little bit, this is a little bit of a trick or like just a helpful thing to know. Like this is something I use all the time, especially because I'm looking at people's graphs really quickly, but also for you guys to know that you are kind of on the right track with your end behavior. What that means is, what do the ends of the graph look like? So similar to what we were just talking about, where you have a graph that has like a, you know, like the exponential growth where one side of the graph is going up and the other one's going out. Being able to make a prediction about that going into the graph, so I know what the ends of this graph look like already without having to graph it. Like I know the two end arrows are both gonna be down. So it's gonna be a down, down graph. And so I know that based off of what I know about the rules of a polynomial. And so this only works though if the x is like a normal variable, not an exponent. So we didn't mention this before because that wasn't the case. This is a polynomial. This is our end behavior rules. So there's kind of two different categories going on here. First of all, if A is positive or if A is negative. So it falls into different categories. Then within that, we can break this up a little bit. So the end behavior depends on the number in front of the x and then also the exponent. So I'll show you guys a little example of this to kind of help that as well. But so for example, if I have a positive number, so like let's use 6. 6 is positive, x, and then an even exponent, so like to the second power, the ends of the graph are both going to go to positive infinity. So the left and the right side. So the graph is going to end up like this. They're both going to be positive infinity. So the limits on those sides would both be positive infinity. Now, I left the middle of the graph open because that depends on the exponent. But if it's even, the ends will always look as I have it drawn. Whereas now, if I have A being positive still, but I have an odd number, the graph is going to look something like this. It's going to look like a, I don't know, what is that? Sideways S, I don't know. So it's going to start down and it's going to end up. So if you can kind of picture like a cactus arms. So on the left side of the graph, it's going to approach a negative infinity. On the right side of the graph, it's going to approach a positive infinity. And this little chart or this little list will help you with this. And I'll show you this in a second with this example. Now when the A value is negative, it just flips this over. So if I use these same examples, so a negative 6x to the second, now it's going to go down, down. So the graph is going to go down. And then my little cactus arms are going to flip. It's going to start up and end down. So that's like the left and right side of the graph. So these kind of tell you the limits without even having to graph this. So I'm going to use this example to show you guys that I don't need to graph it and you shouldn't need to graph it either to know what the end behavior is or the limits are. And I'm going to write it in limit notation just so that we kind of get used to that. So if I'm talking about the limit as x approaches, is it okay if I put negative infinity on this side just because that's the left side? And then I'm going to do the limit as x approaches positive infinity. Now we're going to check it with graphing in a second, but I want you kind of just to try it without. So is my A value positive or negative? In this case.
Negative.
It's a negative, so we're in this region here. Is my exponent, my power, is that even or odd? Even. So I automatically know this situation is going to happen. So these are both going to go to negative infinity. Again, this only works if the x is just like a normal number with an exponent. It doesn't work if x is in the denominator or if it's like part of an exponent itself. So I'll show you guys this graph just so that you can trust me that I'm not just making stuff up. April Fool's Day, let's make everything up. So negative 12, x to the, oh, that's negative 11. because it likes to repeat for me. Negative 12 x to the fourth power.
Yeah.
Okay, so there's my graph. So upside down facing parabola, both ends of the graph are approaching negative infinity. So again, I was able to determine that without having to graph it. And so if it's in that form and you can kind of break down the a and the n, you should be able to use this to help you. Okay. Get these last few done so we can give you guys time for homework here. So they want us to fill in this table, not necessarily using, you don't need to graph it. You want to fill in the table. What it basically is trying to get you to see is the limit from a table. As it gets to a really, really big number, so 1,000,000, what does this become? So we're essentially going to put these values in. So I'm going to do 1 plus 1 over 10, and then to the 10th power. I'm going to put that value in, and I'm going to get an outcome from that. And hopefully it'll help us to see the limit. Be like 2.6-ish, 2.59. And again, just getting used to putting stuff like this into the calculator. And then if you guys have used your calculator, you can actually go back in and edit the previous one. And so I'm just going to add another 0 in there, so you can use the insert button or you can just retype it. And I got like 2.7 now. What's up? I just go, oh, you're fine. I guess I don't know if that's too good. Yeah, I guess I got 2.72 now. Let me know if I'm doing something wrong, if you guys aren't getting the same thing. I got 2.72 again. Something very interesting. Should be at 100,000. So it kind of looks like it's 2.72. That must be my limit. This doesn't seem like a very interesting number. This happens to be the number e, kind of like pi is 3.14. This is the number e. This is the approximation. It's that value e. You wouldn't need to know that, but it's showing us that as we get bigger and bigger and bigger, we're getting closer and closer to that exact value for e. This one wasn't super interesting there. So you have one like that you'll have to do in your homework. Okay? So this allows us to see the limit. All right, last thing we're going to talk about here today is even and odd functions. I always forget these until I'm actually teaching it, is that what an even versus odd function is. It doesn't come up very often unless you're actually in the section. So it basically is saying an even function is if I substitute a negative x in, the function's still the same value. So if I put x equal 2 in, or negative 2, I get the same outcome. That's called an even function. That's like your normal parabola that typically happens, that whether or not it's negative or positive, it gets the same outcome. Whereas an odd function is if I put the opposite value in, I'll get the opposite outcome. So if I put negative x in, the function will change its sign. So for example, if I put x is 2 in, negative 2, and x is 2, I get like the positive version, and then I get the negative version of the answer. So they give me the opposite outcome. Now you can also have neither. So it's even, odd, or neither. So if you don't get anything close, then it's a neither. So we have x to the third power minus 8x. So I'm going to try two different numbers, but the exact like opposites. What number do you guys want to try?
6.
Really? Let me see. I was thinking something smaller, but okay.
2.
2? Or 1? Or 6? You want 6? Okay, 6.
6.
Okay. Okay. So we're going to do 6. So 6 to the third power minus 8 times 6. We're going to figure out what that is. I just like the smaller number, so I didn't have to put in my calculator, but whatever. So I got 168. But then if I do negative 6, now this one you might need parentheses just to make sure you don't lose something there. I got a negative 168. So since it's the opposite outcome, this is an odd function. Now it says without graphing, again, trying to use our rules, describe the end behavior of this f. So again, let's talk about the limits. And I always start from the left just to okay. So we're just looking at that leading the first term, the highest exponent there. What's the a value? What's the the coefficient? Sorry,
1.
It's 1, so it's positive. So we're on the right side of our table. So we're a positive a value, and our exponent is odd. So we're positive and odd. So we're here. So positive a value, odd function or odd exponent. I know even and odd is confusing. So that would tell me I have my cactus arms like this. So on my left side, my arm is going down. So that's negative infinity. My right side, my arm is going up. So that's positive infinity. And these are different functions than the one we were doing on the front side because the x value is like we're now a part of a polynomial here. So kind of watching the difference between those two. All right, so this is kind of a strange question. It says sketch an even function with a relative maximum of 4 and a limit of 0 on the right side of the graph. Okay, so I'm going to start with my axes here. A relative maximum of 4. What does that tell me? What's going to happen in my graph? I have a relative max.
Go straight up.
Straight? What do you think?
It's gonna be the highest.
It's going to be the highest point. So like picture a roller coaster. This is my highest spot. So my highest spot is 4. So somewhere in, and why not, and since it's an even function, I'm just going to kind of put this, I don't know, so like the highest point is 4. So that would be 4 up here. Okay? Now it says on the right side of the graph, the limit approaches 0. So that means over here, the graph is going to head towards 0. So I'm going to do that. That makes sense. So I'm heading towards 0. It's my highest point. Now, if this is an even function, that means if something happens on this side, what's going to happen on the other side? The same thing. So regardless if it's positive or negative, the same thing's going to happen. So I basically am going to draw a mirror image on the other side. So again, I'm trying to head towards 4, so ignore my cruddy drawing, but you get the idea. And just trying to get used to this, you guys. I mean, it's understanding that, this is just going to take practice, just like anything that's new to you. Okay? Questions there? So use your notes as you guys are helping yourself out with this. I'm going to get you guys homework. I have another worksheet for you. Yeah. Yeah.